Okay, lesson 5.3 is the last method of solving these systems, okay? So when we look at it, it's probably the easiest method, but depending on how you're given the equation, it could be different either way. So the first step is this time we're going to write both equations in standard form, right? And standard form is just the ax, right, plus by equals your constant, and align the like terms vertically. So we want to make sure the x's and the y's are aligned vertically. Then what you're going to do is multiply one or both equations, right, by a number that creates opposite coefficients. And explain what I mean by that down here is right now when you look at this, I look at the x terms, and when we talk about coefficients, we're talking about the numbers in front of the variables. Right now when I look at 3x on top and negative 3x on bottom, that's what I'm trying to create, because when I add these equations vertically, 3x minus 3x equals 0x, which eliminates that term. So I could look and see, now I could, when I add them together, one variable eliminates, and I have one remaining. Once I do that, I'm going to add the equations together and solve for the remaining variable. Okay, so that's what I did just here. Then once I have that variable, I'm going to plug the solution from step 3 into one of the equations, it doesn't matter, and solve for the other variable. Okay, so looking at this one says solve the system using elimination. What's nice about this real quick is if I take and look at this, if I add the x's together, do I get 0x? Yes. Therefore, step 1 and 2 is basically done for me. My variables are aligned vertically. They're both in standard form. When I add these together, the 2x's eliminate. And it leaves me with 3y plus 5y is 8y. 11 plus 13 would give me equals 24. Now, what variable can I solve for? Y. I divide both sides by 8. Y is equal to 3. But remember, the solution to a system is the value of the variable that makes both, the ordered pair that makes both equations true. So we have to find x. So I'm going to pick one of the equations. It doesn't matter which one. I'm going to plug y into that equation, and you'll see what happens. I get 2x plus 3 times out with y, in with the 3 equals 11. So 2x plus 9 equals 11. Notice now, what variable can I go and solve for? X. I subtract 9. I get 2x equals 2. I divide both sides by 2, and x is equal to 1. Now, what's my ordered pair solution? 1, 3. Remember, it's always x and y. Okay? Now, when you look at number 2, if I look at my first equation, is that in standard form? Yes. So 8x minus 4y equals negative 4. My second equation, right, is not in standard form. What would I have to do to put this equation in standard form? I have to bring the x term over. Well, how do I get rid of it on the right side? Subtract 3x, which means I'm going to subtract 3x on the other side. Since 3x is negative, I'm going to put negative 3x. Then 4y is positive, so I'm going to add 4y equals 14. Now, if you look, I have my equations written in standard form. I have my x's aligned. I have my y's aligned. And I have my constants aligned. So I check right away. If I add my x's, do I get 0x? No. If I add my y's, do I get 0y? Is negative 4y plus 4y going to give me 0? Yes. Which makes this real easy now. 8x minus 3x is 5x. The y's eliminate equals negative 4 plus 14 is 10. I'm going to go ahead and divide by 5, and x is equal to 2. Now that I have x, I'm going to go back to one of the equations and solve for y. I'll pick the second equation this time. So I write the equation out. Now, everywhere I see an x, I'm going to replace it with a 2. 4y equals 3 times 2 plus 14, which gives me 6 plus 14. So 4y equals 20. And if I divide by 4, what does y equal? 5. All right, so what's my ordered pair solution here? 2, 5. So these are pretty easy ones, right? Now, here's one that has step 2 part of it, okay? So right away when I look at this, I have 4x plus 3y equals 2, 5x plus 3y equals negative 2. They're both in standard form. My x's are aligned, my y's are aligned, my constants are aligned. But here's the thing. If I add the x's, I don't get 0. If I add the y's, I don't get 0, right? So what do I do? Well, here's the thing. I'm going to keep the first equation the same. 4x plus 3y equals 2. But the second equation, I'm going to subtract it or multiply everything in here by a negative 1. So now negative times 5x is negative 5x. Negative times positive 3y becomes minus 3y. A negative times a negative 2 equals positive 2. So if I multiply one thing in the equation by negative 1, I have to multiply everything. Now if you notice here, when I add the y's, what are they going to add up to? Right? They will add up to 0, which is what I want. So now if I go 4x minus 5x gives me negative 1x. My y's cancel. 2 plus 2 is 4. And when I divide both sides by negative 1, I get 4 divided by negative 1 is negative 4. Now I go back to one of the equations. Say the first one. I'm going to use this equation here. Everywhere I see an x, I'm going to replace it with negative 4. 4 times negative 4 plus 3y equals 2. It's going to give me negative 16 plus 3y equals 2. I'm going to add 16 to both sides. 3y equals 18, y equals 6. And right away, negative 4, 6 would be my solution. Okay? So it's very, very, very important to know you have to force these to add up to 0. Which brings me to the next example, right? So in this example, right, if I add the x's, I don't get 0. If I add the y's, I don't get 0. Therefore, what do I have to do? I have to figure out what's the easiest one to eliminate. Is it easy to make the x's opposites or the y's? Well, if I make the y's, I'd have to turn 5y into, say, a 15y and 3y into a negative 15y. I'd have to multiply both equations. But if I look at the x's, if this is 6x, what could I multiply 2x by to make it negative 6x? Negative 3. So in this case, my top equation stays the same. My bottom equation, I'm going to multiply everything by negative 3. So negative 3 times 2x is negative 6x. Negative 3 times 3y is minus 9y. Negative 3 times 15 is negative 15. Now, when I add these together, my x's eliminate. So 5y minus 9y is negative 4y. 19 minus 15 is 4, sorry. And now when I divide by negative 4, I get y is equal to negative 1. If I know y is negative 1, I know 6x plus 5 times negative 1 should equal 19. So 6x minus 5 equals 19. I'm going to add 5 to both sides and get 6x equals 24. Divide by 6, x is equal to 4. Ordered pair solution, 4, negative 1. All right, let's look at the next example. Right now, is the first equation in standard form? Yes. Is the second equation in standard form? The answer to that is no. So, what do I have to do to put this in standard form? I'm going to bring the 3x over by subtracting it. So now when I do that, I would get negative 3x plus 2y equals negative 9. Remember, when I get rid of that, what do I have left? Negative 9. But here's the thing. I have both equations in standard form. All my like terms are aligned. But if I add the x's together or the y's together, I don't get 0. So now I have to figure out which one's easiest to eliminate. This one, you can go one of two ways. It's easy to eliminate the x's or the y's. So if I wanted to eliminate, say, the x's, right? What I would do is multiply this top equation by a number and the bottom, because I can't just multiply 4 or 3 to get opposites. So what I'm trying to do is make this a positive 12x, this a negative 12x, because now they would be add up to 0. So what would I have to multiply 4x to get 12x? By 3. What would I have to multiply negative 3x by to get negative 12x? 4. So if I multiply one term, I have to multiply all terms in the equations. So 3 times 4x is 12x. 3 times 5y is 15y. 3 times 35 is going to be 105. Now, 4 times negative 3x is negative 12x. 4 times 2y is 8y. 4 times negative 9 is going to give me negative 36. So, with this now, 15y plus 8y would give me 23y. 105 minus 36 will give me 69. And now, when I divide by 23, right, you would get y is equal to 3. So now, 4x plus 5y equals 35. I'm going to plug 3 in for y. So 4x plus 5 times 3 equals 35. 4x plus 15 equals 35. Subtract 15, right? 4x equals 20. Divide by 4, and x is equal to 5. All right. So again, your ordered pair solution would be 5, 3. We're going to go down to these questions real quick. When they talk about adding these together, right away you're just adding everything vertically, keeping in track of the signs. What is 7x plus negative 7x? That's 0x. Negative y plus 3y is going to give you plus 2y equals negative 1 plus negative 25 is negative 26. Okay? But now the second one, right? If you're subtracting these, here's what I tell people to do when you subtract. First equation stays the same. I'm going to change this to addition, but then flip the signs on every term here, because I'm basically distributing the minus sign. So now 7x minus 7x is 0x. Negative y minus 3y is minus 4y equals negative 1 plus 25. It's going to give you 24. So this is what you get when you subtract. Okay, so real quick, if I solve these, the first one, right, x's don't add up to 0, y's don't. But if I multiply one of the equations by negative 1, right, that would give me my top equation. Now my bottom equation, multiply everything by negative 1, right? And now when I add these together, the y's eliminate. 3x minus 5x is negative 2x equals negative 6. When I divide by negative 2, x is equal to positive 3 now. So I go back to one of my equations. 3 times 3 plus 4y equals 14. 9 plus 4y equals 14. Subtract 9. 4y equals 14 minus 9 is 5. So y is equal to 5/4. So my ordered pair solution here would be 3 5/4. Okay. Now the next one is nice and easy because if you look, when you add the x's together, they eliminate. So 6x minus 3y is 3y equals 5 plus 7 is 12. Divide by 3, y is equal to 4. So now 3x plus 6 times 4 equals 5. All I did was plug y into this equation. 3x plus 24 equals 5. 3x subtract 24. Subtract 24. And 3x equals negative 19. And when I divide by 3, x equals negative 19 over 3. So the next problem is a little unique, right? Now, when we look at this, both equations are not in standard form, right? So what would I have to do? Well, for this one, I would subtract 4x from both sides. So that would give me negative 4x plus 3y equals positive 5. The second equation, again, same thing. I have to bring the x term over. So I'm going to subtract 4x and get negative 4x plus 4y equals 7. But now, I have everything aligned vertically, which is great, but I don't have, right? I don't have opposites here because negative 4x minus 4x is going to give me a negative 8x. I needed to add up to 0. So here's what I would do. I would just take one of these equations and multiply by negative 1. And if I multiply everything by negative 1, think about this. All that happens is your signs change. That becomes positive. This will become negative. This will become negative. And I can add these together right away. So these eliminate. 3y minus 4y is negative 1y. 5 minus 7 is negative 2. So when I divide both sides by negative 1, I get y is positive 2. And now 3 times positive 2 equals 4x plus 5. So basically 4x plus 5 equals 6. Subtract 5, 4x equals 1. Divide by 4, x is equal to 1/4. And my ordered pair solution, 1/4, comma 2. And that would be my answer. Okay, now right away here, the next one, to put this in standard form, I'm going to subtract 3y from both sides. But since 2x is positive, it's going to be 2x. 3y is now negative, so minus 3y equals, what do I have left over here? 4. The next one, to move this over, I'm going to go ahead and add 3y, but I want to make sure I align the terms. So I have positive x, I have plus 3y equals 2. So 2x plus x now is 3x, because if you notice, the y is eliminated. 3x equals 6. Divide by 3, x is equal to 2. If x is equal to 2, right, then negative 3y plus 2, I took this equation here, negative 3y plus 2 is equal to 2, replacing x with 2. So negative 3y, subtract 2, negative 3y equals 0, y equals 0. Ordered pair solution, 2, 0. All right, over here, again, when I bring the term over, you should recognize that the sign just changes. So bring the 2x over, it becomes negative 2x, and plus 5y equals positive 2. Bring the 2x over, it becomes negative 2x. Since it's minus y, it's minus y equals, since I have got rid of the 2x, I'm left with negative 4 on this side. So again, I already see the x's have the same coefficient. Now I just have to create opposites. And all I'm going to do is change the signs. Positive, positive, positive. Right? And when I add them together, those eliminate. 5y plus y is 6y equals 6. And when I divide both sides by 6, y is equal to 1. So if I take this top equation 2x plus 2 equals 5 times 1. So 2x plus 2 equals 5. Subtract 2, 2x equals 3. Divide by 2, x equals 3 halves. Ordered pair solution, 3 halves, comma, 1. All right, number 8 is like one of the problems, that we did earlier. All I would do is multiply this top equation by -2, because that would give you 2x and -2x. So 2x plus 3y equals 4. -2x minus 4y equals -12. And now, -1y equals -8. Y equals 8. Okay? And if y equals 8, I can plug that back in. X plus 2 times 8 equals 6. I use this equation here. So x plus 16 equals 6. Subtract 16. X is equal to -10. Ordered pair solution, -10, 8. I know I went through these kind of quick, but it was a lot of examples. In here, right, to solve this system, you can multiply the bottom equation by 3, which is what they did here. This step works because of the multiplication property of equality. Right, the next step to add equations, this step works because of the, when you look at it, when you add them together, this is the addition property. All right, go ahead, attempt a quiz. Sorry for the long video.